Hi again, and welcome back. And we're going to start now on lesson 5. And this is one of the very interesting topics actually in this course, what's called structures. We're going to define what structures are in C. And we're going to see how structures keep data together, actually. And keeping data together reminds us of arrays, so we're going to compare between arrays and structures, and we're going to talk about nested structures. Then after that, we're going to see how we're going to use the magic pointers again, and how we use them with the structures, and how we're going to define arrays of structures. Structures, as a matter of fact, are very common in C, and professional programmers use them a lot, and that's why we're going to put in conclusion some general notes on their usage and applications. Okay, let's start and by a basic definition of structures in C. A structure, according to the C language, is a collection of one or more variables that are grouped together under a single unit with a single name. So the structure basically is a collection of different types of variables together in one basket, and that one basket is called a structure, and that basket is going to be given a unique name. The variables in a structure could be of different data types, and that's very crucial and very important to notice from the very beginning. The variables comprising the structure can be anything. I can have integers, floats, characters, arrays, anything you might think of, any standard data type that's defined in C, or any user-defined type that's defined could be a member in a structure. Structures, the main usage of them is to organize complicated data. In many applications, I have sort of complicated data, many parameters that all belong to the same actually logical unit, if you would like. So that logical unit is going to be grouped together and given a one name, and this logical unit with this name is called structure. Let's see. The very traditional example that we use a lot when we first talk about structures is the payroll record. You're an employee working for some company, and for the payroll, to get your money at the end of the day, the human resources will have information about you, so that it knows how much to pay you, your salary, your maybe ID number, all the basic information about you. This whole information is actually, in a sense, is a one unit, a one logical unit. So basically, I would imagine to see on my check stub, my name, my social security number or ID, my salary, maybe my rank, maybe some other data like that. It's all basic information about me as an employee in this company. And I would like to have it all in one unit. So when I say, give me Farouk's, my check stub, I would assume to see on top my name, as I said, my ID or social security number, my salary, and any other relevant information. Okay? I put all of this in C as one unit rather than defining my name as a string, defining my ID as a long integer, defining my salary as hopefully a long integer, big money, and so forth. Okay? So instead of accessing these different variables as separate units, I'm going to give them a logical unit name, and I'm going to always access that whole unit by referring to that name. Let's take a simpler example than this payroll thing, a very basic structure. The structure I'm going to talk about in here refers to the Cartesian coordinate of a point in the Cartesian plane. Any point on the Cartesian plane is actually referred to by its x and y. This is the point I'm referring to. And this is basically its x component in the Cartesian coordinate. And this is its y component. Okay? So this is the xy plane. And to refer to this point, I always have to point to refer to x and y. Of course, these x and y could be integers, they could be float, or they could, it depends upon the actually accuracy we want in the x and y plane. In our case, I'm just simply going to assume that x and y are integers, just for simplicity. However, they can be anything, of course. Okay, let's build now a structure, okay, that refers to this. Okay, instead of referring to two separate integers, one for x, one for y, I'm going to call this a one unit called the structure. I'm going to call it point. And this point thing is going to be a one sort of unit. And whenever I want to refer to the x component, y component within that point, then I will access these components separately within that one unit structure. How to define it? How to declare a structure? Well, in C, we use the word struct. And this is a reserved word in C. And it starts the declaration statement. And then after that comes the name you're going to give for this structure you're building. Okay? And then after that, the structure begins with a brace and ends with a brace. And of course, a semicolon to end the statement like any other statement in C. Now, in between these two braces, I can have what we call the members of my structure. All variables that I would like to see in that logical unit. So in our case, for the point structure, I only have two members comprising this logical unit. They're of type integer. So that's why I'm defining integer x, integer y. Needless to say that these members don't have all to be of type integer, and this is very important. I refer you back to the payroll example. I could have my name, my ID number, my salary, and anything like that. In this simple example, it happens that the two members that I have in my structure are of type integer. So this is basically the definition or the declaration statement of a structure. This is a reserved word, and this is the name, and in between the braces, you have all members of your structure. So again, the struct is a keyword, a reserved word in C that introduces the structure declaration. This is the first thing we write to declare or to define a structure. The struct declaration defines a data type and not a variable, a big not a variable. So when I said something like this, when I do this, I'm not defining a variable called point, okay? This is just a data type, a user-defined data type, okay? Which is comprised of two integer values, x and y, all right? So I cannot assign any values to the struct point, but rather, in my program, I need to define a variable now of type point, and then I can assign values to that variable. Okay? So this is a data type and not a variable. And this is very important. So this way, we're defining new templates, new data types, what we call user-defined data types. So as I said, if I would like to define now a variable of that type, of type point, then the declaration statement will be something like this. Again, I have to use the word struct point. That's the name of this structure. Okay? And in the standard ANSYS C, I have to put this word struct. All right? And then PT1. So now, PT1 is a variable of type point. So actually, PT1 is a basket. Inside it, I have two integers, one called x and the other called y. Okay? Or I can say something like struct point PT2, and this time in my declaration statement of this variable PT2, I'm making an initialization. The way I initialize the struct, if I would like to do it in the declaration statement here, then I need to use braces, the same thing we used in the definition of the structure itself, and inside it I will have the values I would like to assign for the different members. In our case, the structure that we had was something like this: struct point, okay, and I have two variables in here, integer x, integer y, and I ended the declaration like this. Okay, so now when I say PT2 is a variable of type point and I initialize it this way, that means x within this structure is 1 and y is 3. Okay? So this is like an assignment of saying x within that structure equals to 1 and y equals to 3. We're going to see more of this as we move on. So the above declaration, that's the declaration in the previous slide, defines PT1 and PT2 as variables of type struct point. Okay, and these variables, which can be assigned values and which can be manipulated in my program the same as any other variable. Okay, so this is PT2 as a variable, and its values have been assigned to 1 for x, 3 for y. These variables within the structure, in our case, x and y, are called sometimes members of the structures. Okay, so x is a member of the structure point, and or sometimes we could call it element within the structure point. Okay, so I'm going to use the words member and element interchangeably. They refer to the same thing. Okay, how to refer now to x? How about if I want now to refer to x within the structure PT1 or PT2? X by itself is not enough because it's not a variable in my function. However, it's a variable within my structure. So to do that, I need to refer to the structure name and then use the dot operator and then the member name. So to refer to this PT1 variable of type structure that we have already defined, I could access the members of the structure by saying something like this. Let's say PT1 dot, and this is the operator we're using, x. So I'm referring to member x within this structure equals to 1, let's say. This way, I'm assigning a value of 1 to the variable x within the structure PT1. And same thing when I say PT1 dot y equals 3. Okay, so again, what I'm saying in here is that I can refer to the variables within the structure by using the operator dot and by referring to the name of it, then the dot, and then the member name within that. And that's pretty much what we have wrote on this paper and here. Okay? So that's basically how we access members within that logical unit, which we called structure. Okay, let's take another example now, and let's define our structure. Its name is student. It has information about students, apparently. So I'm going to start with the word struct, again, the keyword. Then the name of the structure I'm defining, which is student. And this structure, this time, has 3 variables, heterogeneous variables. I mean by heterogeneous, different data types. For example, the first element or first member of the structure is the name of the student, and the name is actually a string of characters. And that's why we're defining a pointer of type character to refer to the string. And then the second element within this structure is the ID of the student ID. And this is of type long. And then the student grade, okay, which is the third member. And this time, this member is of type float. So as you can see, the members in here can have different types, different data types. Although this whole thing represents a record for a student. And that's actually the exact practical meaning of having structure. And it's a very nice, data type that we have in C language. It's a very powerful data type. Okay, and then that's my structure. So I ended the declaration with the closing the brace and then the semicolon. Okay, I want to assign a variable, define a variable of type student, and then assign values to it. And that's why I'm defining st1 to be my first variable, student number 1, and this variable is of type struct student. So st1 is the variable, and student is the data type, user-defined data type of type structure. And in my declaration statement of this st1, I'm initializing this structure. So the student name I'm having is John Smith. His ID is so-and-so, this long number, and his grade is so. Okay? So that's the declaration statement and initialization, as a matter of fact, of this st1. So again, remember, st1 is the variable, and student is the structure, is the data type. Okay? So basically, when I define my structure, then I'm defining a data type that has 3 actually fields in it. A pointer to character set or to string, ID field of type long integer, and a grade of type float. And then when I define my variable st1 of type student, then actually now I'm reserving in the memory a block of data good enough to hold this record, which is the record of the student named st1. The first entry in here is just a pointer. So in the memory, these 3 elements are contiguous, as a matter of fact. However, this one could be located somewhere else. Actually, all I need, and this is pointers again, all I need about this name is just the starting address of this. So I place the starting address in this name pointer. So actually, this is just a pointer that points to somewhere in the memory where the name John Smith is saved. And then after that, in here, in the ID field, I have the student ID, and then after that, a floating point number representing his grade. Okay? What can we do with the structures? Well, like it's the same thing like we're doing with all other variables we have in C. We can always manipulate variables. We can always perform algebra, additions, subtractions, manipulations, assignments, any kind of things. And that's pretty much what we can do with the structures as well. Structure variables, not the definition itself. The definition itself is just a template, as I said. Okay? So for example, I can assign field. So I can say pt1, we're going back to the point structure, which has 2 members, x and y, of type integer. This is the structure. So pt1 was defined as a variable of type point. And then I can assign pt1 dot x to be 20. So the x component of this structure is set to 20. pt1 dot y equals to 0. So I'm assigning the value of 0 to the y component, or to the y member within the pt1 structure. I can use the field in the middle of my program. And I can use it for making decisions, for example. So this statement, what I'm doing, I'm saying if the X component of the PT1 structure is less than 30, then I would like you to increment the Y component. Okay? So in our case, X was 20, as we have seen in the assignment statement we have made in here. We have initialized X to 20, Y to 0. So, all right, yes, the X component is less than 30, so I'm incrementing the Y component. Okay, so there is an assignment in here, and there is a usage in here of this in the decision-making process. I can assign a structure. I can say the whole structure equals another structure. And that means the individual members of the second structure are going to be copied into the counterpart members in the first structure. So when I say something like PT2, which is a structure of type point, equals to PT1, that way all I'm doing is copying the members from PT1 to PT2. So the X member of PT2 equals to the X member of PT1, and same thing for the Y members. So PT2.X equals 20, PT2.Y equals 20. Okay, so that's like copying a record from one place to another place. I can take the address and refer to the structure by pointers. So pointers, as we said earlier, pointers can be defined to be of any type. Pointer to character, pointer to integer, pointer to float, pointer to anything. Well, part of this anything is actually structure. So I can define a pointer, let's say point PTR, to be of type pointer to structure. So the definition statement could be something like this, as a matter of fact. Struct point, okay, and this is the name of the structure we defined, and then this time with an asterisk here, and I'm going to call the variable point PTR. So this is basically the declaration statement, okay, which defines point PTR to be a pointer of type point, which points to a structure like this. In that case, what I can do, I can assign this pointer to point to the address of PT1. Okay? So this way, I'm making point PTR to point to this structure. Okay? What can we do more? Well, input a field of a structure. I can read a field of a structure from the standard input from the keyboard. So in that case, I'm going to use the library function scanf. And I'm going to read X, and X, of course, is of type integer, and that's why we're using this D format. So scanf, the address, and we know this magical AND, we talked about it before, and then pt1.x. So I'm referring, and this has to be between parentheses this time, to refer to this whole thing, and this whole thing is actually, we're assigning whatever value we read through the keyboard to this member of the structure BT1. I can pass the structure as a parameter to the function. So the argument of the function can be a structure. And in that case, I can say something like my function, which is some defined function, which takes one argument in this case, one parameter, and this parameter is actually PT1. So I'm passing this PT1 structure to this function, and this function is going to work on that and do some processing, whatever. Okay? So pretty much what we're saying in here is that always I can use the structure variable the same way I use any other variable of any other type. I can, as in here, return the whole structure from a function. Okay, so the return value of the function could be of type structure as well. So if you would like, in the definition, this function f, which takes a of type integer as its argument, makes a return value of type point, of type structure. So the return value then is of type structure this time, and it's going to process this integer a, do whatever it's going to do, and when it returns, the return value could be assigned to any structure variable of that type. So let's say in the middle of my program, I can say something like pt3, and I'm assuming that this pt3 is already defined to be of type point to equal to f of 3. Okay? So basically, as I said, use structure variables the same way you use variables. What is the comparison now between structures and arrays? Well, as we have already noticed, structures are heterogeneous data. And heterogeneous means members are not necessarily of the same type. As we have seen in this student record, student structure, which we already defined, I had the name as one member, the ID number, and the grade. Name was of type character, pointer. The ID was of type integer, long, and the grade was of type float. Okay, so basically members can be of any data type. Whereas in arrays, entries, elements of the array are all of the same type. So they're homogeneous data. So if I define my array to be of type integer, then all entries are of type integer. Okay? And that's a major difference between arrays and structures. Each element has to be defined. Of course, since all elements have different variables, then definitely I have to define them separately, individually. I have to specify the variable name, the variable ID, the variable grade, the variable X component, Y component, salary, whatever. Whereas in the array, I just say A of 20, and that means I'm defining the whole array structure in one definition statement, and because all entries are of the same type. So integer a of 20, let's say something like this, a of 20, this actually is a declaration statement that reserves in memory 20 integer contiguous locations pointed by a. Whereas in structures, I have to define clearly, individually, every element within that. And that's obvious because they could be different, as a matter of fact. For example, structure point, which we already have seen, I had to define X and Y separately. Whereas I say something like car A of 5, and all 5 elements, all 5 entries of this array are defined in one shot. Elements are accessed by name. So when I want to refer to any of the elements within the structure, then I have to specify the name, and of course to use the dot operator. So I say a.x, a.y, where a is some type of a structure. Okay? Whereas in an array, we refer to the elements by index. So I say something like a of 7, line of 23. So I'm referring to the 7th element within array I to the 23rd element within the array line. And the last thing, the index in arrays can be computed. Like I can have, if I'm at position I can refer to the previous element by saying a of I minus 1, a of I plus 1. In structures, I don't have that. I have to specifically determine which member within the structure you're talking about. Okay. We're going to move now to what's so-called nested structures. What is that? Well, obviously, since we're saying that within the structure, I can have any type of variable as long as I declare it, define it, then why not having within the structure, okay, another structure? It is at the end some sort of a variable once we define it. Okay, and that's basically what we mean by nested structures. So nested structures basically is to have within the structure definition as elements, as members, other structures. Let's take this example. In this example, I want to define the rectangle in the Cartesian coordinate rather than just one point like we did for the PT1 and PT2 structures we defined earlier. PT1 and PT2 were already defined as variables of type struct point, okay? And they have two components, x component and y component. To define a rectangle, as you all know, we need 2 points on the rectangle, and these 2 points are enough to define or to give all information about the rectangle, like the height, the length, etc. Okay? So I'm going to define now a structure of type rectangle, and that rectangle has 2 main members inside it. The first member is a struct which defines the first point, and the second member is a second struct which defines the second point. The declaration statement goes like this: struct rect, and this is the structure declaration statement, open brace. The first member is of type structure, and this structure is the point structure we already covered earlier. So it has as its first member PT1, which is of type struct point, and PT2 of the same type in this example. And that's it. So basically, after this definition statement, I can perform operations on this new defined structure. Okay, let me define first a field which is of type rect. This is the variable, as rect is the data type, as we already said. So field now is a variable of type rectangle. And then to refer to the any point in this, I have again to give the name of the struct dot the member. Okay, well now the name is field dot the member. Which member we're talking about? The member is a structure PT1, and I'm referring now to a particular member within this structure. So field dot PT1 dot x. So I'm referring to the variable x within the pointer, the structure PT1, which is now a member within field. So in that case, I'm initializing this to be 10. So the x component in here is 10. That's what we're saying. And field dot PT1 dot y, which is the second component in PT1, equals to 10. Same thing for the PT2 dot x 20, PT2 dot y 30. So this way, actually, I'm defining all elements within the structure field. These are assignments. We can do manipulations, processing, like I can define a variable of type, let's say, length, to refer to the length of this rectangle. And definitely, as we all know, the length is the, if you like, the x component here of PT2 minus the x component here. And that refers to this distance. Okay? So basically, this distance can be calculated as field dot PT2 dot x minus field dot PT1 dot x. So it's the x component of the second point minus the x component of the first point. Height, on the other hand, is the y component of the second point minus the y component of the first point. So height equals to field dot PT2 dot y minus field dot PT1 dot y. So I'm referring to a structure within a structure, and that's what we mean by nested structures. I can refer to structures by using pointers as well. And in that case, as we all know, instead of passing, let's say, the structure by value to the function, to where its contents can't be changed, I can pass a pointer to that. And passing a pointer is much more economical, and that's why we always encourage to use pointers in C, as they are more efficient. We have said they're faster. And now, this is a second advantage of using them. When I pass the entire structure, that means I'm copying the entire big basket to wherever I want to send it to. However, when I pass just the pointer, I'm just passing 4 pointers rather than the entire block. And this is more economical in terms of storage and memory. So, okay, in that case, I can define my variable bt1 to be of type pointer, and we have seen this a little bit earlier. Okay, and now to access any element within this structure, I can say something like the value of pt1.x is 3, or the value of pt1.y equals to 5. Well, there is a better way of doing this. This is definitely correct, no question about it. But usually, instead of doing this, we use a special operator, and that's the arrow, the minus sign followed by this greater sign. So when I define, if you like, my pt1 to be of type pointer, like this, struct point star pt1, and then to refer to the x component now, I write something like pt1 arrow x equals to 3. And that means I'm assigning a value of 3 to the x component within this structure. So when pt1 is a pointer, I use the arrow. When pt1 is a variable, okay, not a pointer, a value, then I use the dot operator. Remember that, it's very important and very crucial. I can define arrays of structures. Let's say my structure key has 2 members in it, a word of type pointer to a character, a string, and integer count. Okay, and I'm introducing this. I will talk about this in a minute. Okay. Given this is a typical structure, nothing new in here. This declares a structure of type key. And then the declaration key tab, this is the variable name, array of size n keys. This way, I'm reserving in memory actually an array of structures. The number of entries in this array is n keys. Each entry is actually a structure of type key. Okay? So this way we're defining array of structures. Actually, this reserves as a storage for it in the memory. Before I get to the final remarks, let's go back to this word that we introduced. Okay? When I said struct, let's say, I'm going to refer to this example again, point, and we defined integer x, integer y. Okay? Now, I used to close in here. This time, I'm saying something like is point. What is this is point? Well, this is a logical name that I'm going to use for this structure. When I defined my variables bt1 and bt2, I used to say something like struct point pt1. Okay. Well, instead of keep repeating this word, I can give a logical name to this structure is point, and I can say directly is point pt2. So pt2 actually is a variable of type struct. Okay, so this is just to make the writing a little compact. So just final remarks. A structure declaration that's not followed by a list of variables reserves no storage. It's just a data type. It's just a template. Okay? No storage whatsoever is reserved in the memory. A structure can be tagged for later use in variable declarations. And this tag is this word we're adding in here. So for the point structure, which has x and y, I'm adding this is point as a tag or a logical name for this. So when I define my variables then, I can say is point pt1, comma pt2, so pt3. So pt3 and pt1 are of type point of this structure type. And this is actually equivalent to saying struct point pt1, pt3 instead of 2. Sorry for that. Okay? So that's pretty much what I want to talk about in structures. And much more examples and exercises are available on the internet on the UNINETTUno site. And if you click on the MedNetU link in there. Thank you very much, and I will see you next time.